Okay, so this is chapter 15, the function chapter for my book, Overcoming Digital SAT Math by Sofia Garcia. So if you have a copy of this book, for the best results, I recommend that you attempt the problems on your own first, attempt corrections on your own first, and reference this video on YouTube for anything that you need explained that you can't figure out on your own when doing corrections. And then also, I'll link in the description a corresponding ACT version of this video for anyone that needs like a quick little lesson with other problems before attempting these problems. So let's get started. So this one says, for number 1, given that f of 11 is equal to f of negative 11, which of the following must be the function f? So this is basically saying when we plug in 11 for x, we want to get the same thing as if we plug in negative 11. So if we plug in 11 right here for x, we would get 2 times 11, that's 22. If we plug in negative 11, we would get negative 22. Those are not the same. So then let's try it here. If we plug in 11 up here, you're going to get 11 to the 5th over 2. But if you plug in negative 11 for x over here, you're going to get negative 11 to the 5th over 2. Now, you could solve this all out if you want, or you can say, okay, I know that these are not going to be the same value because if I have an odd number as an exponent with a negative inside, then that means that my final answer has to be negative. So this is going to be a negative value, and this one's going to be positive. So they can't be the same. Now, let's erase that and look at the next one. So, again, I plug in 11 for x. So that would be 4 minus a minus is plus. So 4 plus 11, that's 15. And now I'm going to plug in negative 11. So negative of negative 11 is just positive 11. So 4 minus positive 11 is just going to be negative 7. And those are not the same. So we would cross that out. Hold on, there's a piece of lint that's bothering me on this. Okay. So now let's go to D. Someone said, where were you when I was struggling with math my freshman year? Well, I'm here now. So now let's go to D, which obviously has to be the answer, but let's verify it. So we would have 2 and then in parentheses 11 for the x value to the 4th power minus 4. And then we want to say, okay, now what about if we plug in negative 11 for x? These would be equivalent. They're the same thing because it's being raised to a positive exponent. So if you have a negative value raised to a positive exponent, it's going to be positive as well. So 11 to the 4th is the same thing as negative 11 to the 4th. Everything else is the same, so they have to be equal to each other. So D. Okay, so let's look at number 2. So we have this function, and then we have to assume that g of n minus 3 is equal to 0, and n is a constant greater than 0. What is a possible value for n? So this portion right here, n minus 3, is going to be replacing each of the m values here. So anywhere we see an m, we put an n minus 3, except when we're doing, well, technically you could just start by doing that. Let me just try to be consistent with how I'm saying it. Some of you may already know what like the step I was going to say next is and can skip ahead to that, but let's do it one at a time. So n minus 3, I'm going to put everywhere that I see an m. So n minus 3, minus 4, n minus 3 goes in that place for m. So then now, what I was going to say before, and you could skip to this step if you want, is instead of g of n minus 3, I'm just going to put a 0 because I know it has to equal 0. And then I'm going to simplify these, so I'm going to have n minus 7 times n, and then minus 3 plus 3 is just cancels out, so we just have n right there. So each of these factors, when they equal 0, can get you that result of 0 after you multiply. So we could technically say n minus 7 equals 0, and n also is equal to 0, but the problem is the question told us that n has to be a constant greater than 0. So it can't be this one based off of that. But if we add 7 to each side over here, we see that n is equal to 7, which is a constant greater than 0, so that has to be our answer. So let's keep on going. Thank you guys for the likes and shares. So let's keep going to number 3. We have f of x is equal to all of this, and we want to find what does x equal at the minimum value. So another way of thinking about this that you guys are probably more familiar with is the formula where it's x min or x max, in this case it's a min, is equal to negative b over 2a, that formula. When you're looking at a parabola or quadratic, same thing. So if we want to find the x min, which is what it's asking, we have to figure out what b and a are and then plug it in to that formula. Now, you'll see this doesn't look like your typical parabola quadratic thing where you start with an x squared term. In order to have it all written out nicely where it's like x squared plus something times x plus the constant, we're going to have to FOIL this all out. So that's what I'm going to do. F in FOIL stands for I'm multiplying the first things together, so 3x times 2x, which is going to be 6x squared. O stands for I'm multiplying the outer things together, so negative 6 times 3x, so that's going to be negative 18x. I stands for multiply the inner things together, 4 times 2x, so that's going to be 8x. And then L stands for multiplying the last things together, so 4 times negative 6 is going to be negative 24. Now I'm going to combine my terms right over here. So I'm going to get that this is just 6x squared minus 10x minus 24. Now I can easily see what b and a are. So A is going to be the value right here that's being multiplied by x squared. B is the value being multiplied by the x, so negative 10. So if I want to find the x min, I just need to do the negative of what b is, which is negative 10, over 2 times what a is, which a is 6. Negative of a negative is a positive, so this is really 10 over 12. Then if I divide by the greatest common factor on top and bottom, I get 5/6 as my answer. So let me just erase that a little bit and we'll move on to the next question. Okay. So now number 4, it says the function f of x is graphed below for how many values of x is f of x equal to 10. So f of x is equaling 10. That means basically the y is equal to 10. So let's look everywhere that the y is 10. So at this point y is 10, at this point y is 10, and at this point y is 10. So there are 1, 2, 3 different x values where f of x is equal to 10. So let's see which one says 3. That would be answer choice D. Okay, so now let's go to you don't have to factor. What do you mean? Oh, for this one, I think is what you're referring to. No, because you're trying to find the x min. You're not finding you're thinking of if I was finding the x-intercept and I set this equal to 0, and I needed to solve for what x was when f of x is, or when I have f of 0, basically when the y is 0. That's what you're thinking of. This is a different type of question. This is the x min type of question. So let's go to number 5. So for number 5, what is the y-intercept of the graph of the function shown above? So y-intercept, with intercepts, just remember the opposite variable is 0. So if I'm finding y-intercept, my x is going to be 0. So that means that 1/2 to the 0, that's 1, plus 6. So then my y-intercept is going to be equal to 7. Okay, hold on, I have OCD and I really don't like that. Okay, so then let's go to number 6. Okay, so for this one we have, is it not 6? No, because you're, another common mistake that people make, anything to the 0 power is equal to 1. People think it's the same as multiplying by 0, but it's not. Anything to the 0 as an exponent is just 1, so it's 1 plus 6. So now let's go to number 6. So if the linear function f is defined by this equation, what is the value of f of 5? So you see how 5 is in place of what x is right there? So that just means we need to have 5 replace all the x's to find f of 5. So f of 5 is equal to 3 times 5 minus 2. So then that's going to be 3 times 3, which is 9. Yes, Sunny, you're right. It's 9. So then let's go to number 7. We have this table right here, and it's showing that this table is related to this function, and we need to assume that m and n are constants. What is the value of n? Okay, so we're finding out what n is. This is the same thing basically as these XY tables that you're used to. It's just that it's written sideways. So like if we're thinking of it as X and Y, kind of like it's just sideways like this. And Y just happens to be represented by g of x is the easiest way I think for most people to comprehend this. So we have a bunch of points that they've given us. They've given us the point 0, 4, they've given us the point 1, 12, and they've given us the point 2, 36. So we can just plug in values to figure out to help us figure out what n is. So let's do that. Let's say, okay, well, g of x I'll say is 4, and that's going to equal m n 2. Actually, I'll tell you an even easier way to go about this before. But let's just keep going with this. So m times n to the 0, remember anything to the 0 is 1, so it's 4 is equal to m. And then you could figure out, oh, 4 is m always, so then you just plug in another point to figure out what n is. What you also could have done is you could have just seen that this was an exponential function, so you know that with exponential functions, whatever you're multiplying by on the outside has to be like the starting value, like it has to be basically the y value when x is 0. So you could have just known that based off the characteristics of exponential functions as well. Someone asked, do we just plug both values in? Yeah, I plugged in both. So I plugged in for x and g of x. So now what you can do if you're solving it this way, also we could just keep going. That's what m is. So now we can say, oh, I'm just going to use another point. So I'll use 1, 12. So 12 is going to be my g of x. And then I'm going to say, okay, I'm solving for n. And then my x value is going to be 1 when g of x is 12. So then I'm just going to divide by 4 on each side, and I get n is equal to 3. So there's a bunch of different ways to think about it. You could think about the characteristics of an exponential, or you could just start plugging in corresponding values for x and g of x, and then solving as needed. So for the person that said I don't get it, all I did was I said, okay, I have a bunch of points. I'm going to start plugging them into the function they gave me right here to help me figure out what m is. Then once I have m, I could plug it in to figure out what n is using another one of the points. That's all I did. Okay, so let's go to number, 8? So number 8, g of x is equal to all of this. The function g is defined by the equation shown above for what value of x is g of x equal to -2? So here you see g of x is equal to -2. So I'm going to replace g of x with -2, and then I'm going to copy over the rest of the problem. So now, remember, I'm solving for x, so all I have to do is just distribute, then combine like terms and solve for x. So this is -2, -5 times x is -5x, -5 times -2 is going to be +10, and then we have just the +3 to copy down over. Now let's combine these like terms of 10 plus 3 to get 13. So then I have -2 is equal to -5x plus 13. Now I'm going to subtract 13 on each side. So then I get -15 is equal to -5x. and then divide by -5 on each side, and then I'm going to get x is equal to 3, so the answer should be B. Someone asked, is this considered algebra 2? This is like incorporated into a bunch of different maths. So I've seen this as early as pre-algebra. So it really just depends on like how your school does it. But like you start doing basic function stuff with pre-algebra, and then you usually like get first introduced to it there, but you keep reviewing it and it keeps getting harder as you progress through the different algebra courses. So let's go to number 9. Based on the table above, which of the following could be f of x if y is equal to f of x? Okay, so y is the same thing as f of x. So again, they've given us a bunch of points. We have 0, 5, 2, 9, and 4, 21. So what you can just start doing is plugging in. I would start with the 0, 5, because that's easy as it has a 0 in it, and then see what you can eliminate based off of that. So if I plug in 0 for x, do I get 5 for f of x? So if I plug in 0 for x here, I do get 5 for f of x, so that works. So it could be A. But if I plug in 0 here, 5 times 0 is 0, not 5, so it can't be that one. If I plug in 0 for x right over here, I do get 5. If I plug in 0 for x here, I do get 5. So it helped me eliminate 1. After that, what you can do is just pick the next point, 2, 9. You could also pick like 4, 21 if you want, doesn't matter. So now I'm going to plug in 2 for my x, and I'm going to say, okay, do I get 9 for my f of x? Well, I do not. I would get 7, so that's not it. Now let's plug in 2 for x over here to see if we get 9. So that would be 2 times 2 squared plus 5. So that's going to be 2 times 4, which is going to be 8, plus 5 is definitely not going to be 9. So it's not that one. So then we would do the same thing with D, plug in 2 for x, see if you get 9 for f of x. So that'd be 2 squared plus 5. And then that would be 4 plus 5. And that does equal 9, so it works. Yay, Julie got it. And so did Kay. Good job. My flex is I already know how to do that. Again, can you do some absolute value functions? I'm in 8th grade and don't really understand. So I'm doing just regular functions tonight. I forget if the functions chapter has absolute value in it, but there is a standalone absolute value chapter that I'll be doing and putting up on my YouTube for sure if you missed the live, if I decide to do a live for it. Because I have to get all these videos up by the 31st. So let's go to number 10. So it says, what is the value of f of 0 if f of x is the function graph below? So you see 0 is replacing the x right there. So if we want to find f of 0, we need to find at x equaling 0, what is the y basically is how you can think about it. So when x is 0, the y right here is going to be, each of these squares is 1, so -5, -6, -7, -8, -8. So that would be C. And then let's go to number 11. So for number 11, the function h is defined by this. What is the value of h2? Again, inside the parentheses is a 2, so that's going to replace everywhere that we see an x. So h of 2 is equal to 4 to the second power, which is equal to 16. And then good job to everyone that got that. And then let's go now to number 12. So if g of x is equal to this, then for which of the following values of x does g of x equal x? Okay, so again, just like it's kind of a lot of, I would say most of algebra and pre-algebra is just like finding patterns and like it's kind of like a puzzle, like replacing things. So like g of x is equal to x, so in its place we can just put x. So x is equal to 3x root x, because x is the same thing as g of x, it says. And then we figure out, okay, what value of x does this happen for? What you could technically do, if like you're bad at solving and isolating variables, is you could technically just plug in, like for x, plug in 1/9 there, 1/9 there, and 1/9 there, and see if this works. And you could do that for each of the answer choices. And actually, that would probably be the fastest way for most students, I would say. Yeah, probably. At least for me, I feel like I could do that pretty fast. So I would start with the whole numbers if you do that. And I would go like 9 is equal to 3 times 9, and then root 9. And then obviously you could do this in your head too. So 9 is equal to 27 times 3, definitely not. So it can't be that one. Like, start with the easy ones first. And then do the same thing with 3. So 3 is equal to 3 times 3, root 3. So then that's going to be definitely not it, because 9 times root 3, no. So let's erase that. And I'll show you both ways to do it also, but this is the way you would do it plugging in. So then that would be 1/3 is equal to 3 times 1/3, 3 times 1/3, yeah. And then root 1/3. So 3 times 1/3 is going to be 1, like that just cancels out to 1, so then you have 1/3 is equal to root 1/3, no. So did I click the pen? Yeah. Whoops. Okay, and then we're going to have 1/9. 1/9 is equal to 3 times 1/9, root 1/9. So then 3 goes into 9 3 times. It goes into 3 once. So 1/3 times the square root of, wait, did I do that right? 1/3 times the square root of 1/9. I was thinking it was, my brain like flips numbers all the time. I was seeing it as like 1/9 on the outside and 1/3 on the inside. I was like, wait a second. So then now what we have to do is we have to simplify the square root of 1/9. So I'm just going to copy over the other stuff really quick. And then we're going to say, okay, this is the same thing as if we separated it to be root of 1 over root of 9. The square root of 1 is just going to be 1, and the square root of 9 is just going to be 3, so then it's just 1/3 times 1/3, so then it's going to be 1/9, and that does work out. So it would have to be A. So that's how you would do it with, like, the plug-in method. Now, if you wanted to, like, solve it without the plug-in method, like, you could say, okay, I'm going to divide by x on each side, so then this cancels out to 1, and this just cancels out again to 1, but then it's just, like, 3 root x is left over. So you could say, oh, I have 1 is equal to 3 root x. Then you divide by 3 on each side to get root x is equal to 1/3. Then you have to square each side to get x by itself, because the opposite of square rooting is squaring. So then when you do that, you get x is equal to, and then 1/3 squared is just 1/9. Someone asked, do you do videos on the English section on the SAT? Yes, I have videos already up, because what I do is, or what I have been doing previously is I wrote a whole entire book for, like, ACT English, but the grammar stuff is so, like, similar on the SAT, like, paper version and digital version, that I've used it for prepping students for both, but I am going to do, like, a solely digital version book. So you can still, like, watch the videos of the ACT to learn, like, the basic grammar rules and stuff. I have that whole playlist up on YouTube. So then, yeah, you have a placeholder of 1. Yes, I do have a YouTube. It's the same name as this, AG Tutoring. So it cancels out to 1, just like I wrote it there. So then let's go to, isn't 0 if it's one of those answer choice is. If it's, wait, what are you trying to say? If x isn't 0, if it's, oh, I see what you're doing. You're getting confused by, like, it could also be 0 if you plug in 0 for x, it works. Yeah, but it's not in the answer choices. Got it. Okay, so let's go to number, okay, sorry, you guys are funny. Okay, number 13. So f of k is equal to all of this, then we're finding f of 1/2. So 1/2 is going to be replacing everywhere that we see a k. So let's do that. F of 1/2 is equal to 1 over 1/2 squared. plus negative 1 over, and then 1/2 on the bottom right there. So 1/2 squared is just 1/2 times 1/2, so it's going to be 1 over 1/4. And then plus a negative is just subtracting, so that's why I'm just writing subtraction. And then minus 1 divided by 1/2, which would just be the reciprocal. You can think about it, or you could do it all out as keep, change, flip if you want. So like you could say 1 over 1 divided by 1/2 is keep, change, flip is just 1 over 1 times 2 over 1. You could do it that way, or just know that if you're dividing by a fraction, you're multiplying by the reciprocal. So minus 2 right there. Same thing applies to the 1 over 1/4. 1 divided by 1/4 is the same as multiplying by the reciprocal 4, so it's just 4 minus 2, which equals 2. Okay, so now let's go to number 14. So f of x is equal to this. For the function given above, the domain is represented by the following set. So domain is just like the x values, like the possible x values. Based on the context, which of the following could be the range of f of x? So like if these are my possible x's, what are my possible y's or f of x's, is what it's basically asking. So these are my possible x's, so let's plug those in. So f of 2 means that x is going to be 2. So then I'm going to have the square root of 2 plus 2, which is the square root of 4, which is just equal to 2. And then we're going to say, okay, well, what about if I have f of 7? What if my x is 7? Because that's another possibility that we were given. So then it's going to be the square root of 7 plus 2, square root of 9, which is just equal to 3. And then we're going to say, okay, what about if we have f of 14? Well, if we have f of 14, then that's going to be the square root of 14 plus 2. I'm running out of space, which is equal to the square root of 16, which is just 4. So it's going to be 234a. So if it's f variable equals blah, 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 and f number, then you would just plug in the number for the variable. Yes. That's why I said it's kind of like a puzzle. It's just like taking its place. Taking place of like the variable. So let's go to number 15. So for number 15, if f of x is equal to all of that, then f of 3 plus b equals, so here, be careful with that logic, because it's not always going to be like just plug, like you can't just plug in 3 for x. It's whatever's inside the parentheses have to replace each other. So like if I want to find f of 3 plus b, that means that 3 plus b is taking the place of each of my x's. So that's what I'm going to do. I'm going to say, well, I'm just going to make this an equal so I don't have to rewrite that. So I'm going to say, instead of x squared, I have 3 plus b squared, which is the same thing as 3 plus b times 3 plus b. And then we're going to have plus 4 times x is going to be 3 plus b, and then minus 5. So now, remember, whenever you have two terms plus or minus in parentheses times 2 terms plus or minus in parentheses, you have to FOIL. FOIL is the acronym that stands for what you multiply. F is meaning that you multiply the first thing, so 3 times 3, which is 9. O is multiply the outer, so 3 times b, so that's just 3b. I is multiply the inner, so b times 3, 3. I keep writing my 3's like that, 3b. And then L is the last that you multiply, so b times b is b squared. And then you're going to distribute this 4 to each of the terms in parentheses, so 4 times 3 is going to be 12, and 4 times b is 4b. And then minus 5 we just copied down. And then we're now going to combine any like terms. So I see that there's a like term here, and like term here. So 3b plus 3b is 6b, 6b plus 4b is 10b. So I'm going to have, and then b squared doesn't have any like terms, so I'm going to go ahead and copy that down. So b squared plus 10b, and then I have these like terms right here. 9 plus 12 is going to be 21. 21 minus 5 is going to be 16. So plus 16. So that would be answer choice, I lost it. Okay, B. There it is. Someone asked a question, is the real SAT this easy? So just remember, it is, I will say the digital SAT is significantly easier, even though the College Board says, oh, it's not, it's like, we accounted for that or whatever. Like, it's significantly easier than the old one. I mean, you can even just see that with the word problems. The limit on, like, the number of words that are in each of the word problems is, like, way less. But also remember, this is just one concept. This is the functions chapter. So it's not just these types of questions. What level is it, please? So, you take it, usually your junior year of high school. So, like, that would be, like, it's the stuff that you should know by then. But everyone's always at a different level in math. So then, let's go to number 16. If f of x is equal to x squared and g of x is equal to that, what's g of f of x? So, these are the ones that get people. But it's the same sort of concept. So, what goes in your parentheses for g of x right here, instead of an x, you're putting what f of x is equal to. So you're really finding g of x squared. So everywhere you see an x, you're replacing it with an x squared because that's what f of x is. So it's going to be x squared minus 4. So it would just be a. And then let's go to number 17. Use the graph of the function below to answer the question. So if f of b is equal to f of 0, which of the following could be the value of b? So first let's figure out what is f of 0. So what is f when the x value is 0? So when x is 0, then we're going to have that f of 0 should be right here at -3. So I'm going to say that that's equal to -3. So that means that f of b has to also equal -3. So there's these other points that have been labeled that have a value of -3 as well for their y value or their f of whatever value. And we see, okay, when does that happen? For what x value, which we're representing with the variable b, well, that happens when x, or in this case b, is equal to -0.5 or positive 0.5. So which of these could be the value of b? Well, it could be C. So let's go to, wait, did I skip one? No, that's 18. So, there we go. Okay, based on the graph shown below, for how many, it's a little fussy, there we go. For how many values of x does f of x equal h of x? Assume f of x is the parabola and h of x is the linear function. So basically, it's asking where do these equal each other? Where do their y values intersect is probably the easiest way for you guys to think about it. Or for how many values of x do the y's meet of these two functions. So right here they meet, and right here they meet, and that's going to be at two different values for x. So it would be 2. So then let's try number 19 now. So for the function given above, the domain, meaning the possible x values, are this. Based on the context, the range of g of x, meaning the possible y values, include all of the following except, so remember, that's important, except we're looking for what it can't be, basically. So let's start with what it can be. So the x is going to be greater than -7 or less than 5. So let's figure out what is g of -7, meaning what happens when we put in -7 into g of x. So everywhere I see an x, I'm going to put a -7. So I'm going to get -49 minus 5, which equals -54. Now let's figure out what happens when I put in 5 for my x. So when I put in 5, 7 times 5 is going to be 35, and then minus 5, so that equals 30. So I can have y values, or g of x values, you could think of it like that, between -54 and 30. So I'm going to just kind of write it like that. Negative 54. So g of x is between negative 54 and 30. So which of these basically does not fit that criteria is what we're looking for. So right away, it can't be equal to 30. It has to be less than 30. So I see D is not possible. So you would have to solve this equation graphically. No, you don't need to graph this one. Domain and range doesn't mean you necessarily have to graph. Just think of domain as like possible x values, and your range is your possible y values, or g of x values in this case. Basically, like, I mean, this is oversimplifying it, but for most people it's fine. Like, it'll get you through all of math in high school and everything, and probably a lot of college. To just simplify it to say, like, when we say a function like f of x or g of x or like h of t, whatever it is, just think of it as the same thing as y. Like, basically. Oh, no, I meant for number 18. Well, for number 18, you would be provided the graph. So, like, just like it is here, you're given the graph, and then you have to see, you have to, like, look at it to answer the question. So you don't need to graph it because it's already given in the graph. So now let's go to number 20. So for number 20, for the function f shown above, which of the following would contain all values of x for which the function is not defined? So not defined is a kind of just like an obnoxious way of saying, like, when it doesn't work, when the function doesn't work, when the function, like, something impossible happens with the function. So, like, this function doesn't work if we have negatives, like a negative value inside of a square root, because that's when we start working with, like, imaginary complex numbers and all of that. So we have to say, okay, when is this going to equal a value that is less than 0? So let's think of I'm trying to think of, like, what the fastest way to do this would be. I guess it depends on, like, if you're really good at mental math. If you're good at mental math, what you can do is, like, really easily pick numbers that fit, and just, like, see if it ends up, like, giving you a value that's less than 0. Like, you could pick 3 in there and then plug it in for A, like 3 is a number between 2 and 10, and then see if you get a number less than 0, and then you could keep doing that. But, like, with the next one, B, 3 works for both of these, but for B, you want to pick something that doesn't work for A. Like, you could pick maybe, like, 0 or something. So, like, it depends on if you're, like, good at mental math or not. I would probably just see when does it equal 0, and then play off of that. So I would say, okay, when is the inside equal to 0? Because then I know if I go in a certain direction, I'm going to get a negative value. So I want this to end up being less than 0, but right now I'm going to pretend it's equal to 0. So I'm going to say that I have x, that's going to be minus 4 times x minus 2 to get it to equal 0. So then x would have to be equal to 2 or 4 to get you that value of 0 when you multiply these. So then you would just have to, I mean, you kind of do have to test it out anyway mentally afterwards. I try to like think of the most efficient way to do this, and, like, from multiple perspectives. So sorry, I'm, like, talking to myself. So x could be 2 or 4 to get you to that 0. But then, yeah, you're going to have to test values anyway. So I would test, like, 3 squared minus 6 times 3 plus 8. Do I get a negative value? That's going to be 9 minus 18 plus 8. And yes, that does give you a negative value, so that works. So then you have to say, okay, well, now I'm going to try something like 0. 0, and in for x there, 0 squared is 0, minus 6 times 0 is 0, plus 8, you're going to get a positive value. So 0 would not work. Like, x could not equal 0. Wait, hold on. X could not equal, I'm trying to, how do I say this? It works, so it doesn't work for the problem. It's annoying to say because it's like, not defined is like, when does it not work? But I meant, like, it doesn't work in the context of this problem. So basically, if we plug in x is equal to 0, we don't get a negative value inside the square root, which is what we want for this to not work. So it can't be B. And 0 also falls into the category for C. So we could cross out C. So then now we just have to determine, okay, is it A or D? So let's pick a value that fits for D but not for A. So we could pick something like 5, because 5 fits into this but not that. So if we plug in, let me just erase. If we plug in 5, we would have 5 squared minus 6 times 5 plus 8. So then that's going to be 25 minus 30 plus 8. So then that's going to be negative 5 plus 8. So that's just going to be positive 3, which remember we wanted a negative value in there. So it's not going to be D, it has to be A. So yeah, it would probably just be the fastest to just plug in for this one. Like just from the start and not even have to factor, because they already gave you the values of 2 and 4 that like would be the whole point of you solving it first to narrow down answers. So then let's go to number 21. If f is a linear function and if f of 3 is equal to 4 and f of 5 is equal to 2, then f of negative 102 is equal to. So think of it like this. We've been given 2 points right here. We've been given 3 as our x and 4 as our y. Oops. Let me erase that. Why is it not doing it? There we go. And then we've been given 5, 2 as well. So if we have 2 points and they tell us it's a linear function, remember linear function, I mean, if we're just thinking in terms of f of x instead of y, to be all like technically correct and everything, y is equal to mx plus b, or f of x is equal to mx plus b. We just need to figure out what is m and what is b, and then we have an equation that we can plug negative 102 in for x to solve for f of negative 102. I know that's a whole jumbled up mess. You're going to see in a second what I mean. So let's start with, I need a slope. I need m, so let's plug in these 2 points into the slope formula to find m, or slope. So I'm going to do 4 minus 2 on top, and then I'm going to do 3 minus 5 on bottom. So then that's going to be 2 over negative 2, which is just negative 1. So I know that my slope has to be negative 1. So now what I'm going to do is I'm going to say, okay, I'm going to now use one of these points. It can be either one. I'm just going to pick the 3, 4 one. And I'm going to say, okay, my x is going to be 3, my f of x is going to be 4. I know what m is now. Now let's solve for b. So instead of f of x, I'm going to put a 4. And then I know m is negative 1. And for x, I'm going to put 3. And I'm going to say, okay, now I can solve for b. So I have 4 is equal to negative 3 plus b. So I'm going to add 3 to each side. So then I'm going to get 7 is equal to b. And then now I can plug that in here to have a full equation. So now that I have the full equation, which I'll rewrite right here, f of x is equal to negative 1 times x, which is just negative x, plus 7. Now that I have that, I can plug in negative 102 everywhere I see an x to find f of negative 102. So that would be the negative of negative 102 plus 7. So then negative of negative is a positive, so 102 plus 7. So that's going to be equal to 109. So that's my answer. Let me just get water really quick, guys. Okay, so what are we on? Number 22. Let me just erase this so it's out of the way. Thank you guys for the likes. Okay, so now let's go to number 22. So given that g is a linear function, we have, so again, we've been given 2 points. So let's write that down. Our 2 points are going to be 5, negative 10, negative 3, 7, and we want to find the y-intercept. So let's, basically it's very similar to the problem before. It's a linear function, so let's start by finding the slope. So I'm going to do negative 10 minus 7 over 5 minus negative 3. Minus and minus is a plus. So this is going to be negative 17 over 8. So that's my slope. So if I'm writing out the linear function right now, I'm going to have g of x is equal to mx plus b, with my m being negative 17/8, and then x plus b. So I'm trying to find b, the y-intercept. So now, just like I did before, I'm going to plug in one of these points. I'm just going to use the 5 comma negative 10. So negative 10 is my g of x that I'm going to plug in. And 5 is going to be my x. So I'm going to have negative 17/8 times 5, and then plus b. So I'm now going to say, okay, I have negative 10 is equal to, 5 is the same thing as 5 over 1. So I'm just going to multiply the top, so then that's going to be negative 5, carry the 3, that's 85 over 8. Let me just make sure, because at night my calculations get all messed up. So 5, carry the 3, yeah, negative 85 over 8 plus b. And then now I'm going to isolate b by adding 85 over 8 to each side. So then I'm going to have negative 10, which is the same thing as negative 10 over 1, plus 85 over 8 is equal to b. Now remember, when I add or subtract fractions, I have to have a common denominator, so I have to multiply by 8 on top and bottom to do that. So I get negative 80 over 8 plus 85 over 8. So I'm going to keep the common denominator, 8 on bottom, and then I'm going to say, okay, I'm going to add the numerator. So negative 80 plus 85 is going to be positive 5 on top. So the answer would be 5/8. And let me just erase that. Okay. Okay, it's number 23. So for number 23, and then this is just like a little disclaimer that on the digital SAT, they don't give you like multi-part questions referring to like the same table or same like wording of a problem like they used to. I just did this to save paper. So like these, if you saw these, it would be like the question in isolation, like just number 23 or just number 24, something like that. Hold on, I just had a client text me. Why did she say that she has a session? Hold on, let me check my calendar. No, there's no session today. If I go out of a live to text somebody, is it going to cancel the live? Does anyone know? If it does, I'm just going to text her right back really quick, but if it does, I'll be right back on. Okay, there we go. Okay, so let's keep going. So we're on number 23 now. Hold on, let me just see. Yeah, it's not today. Okay, I was just double checking. I got paranoid. Okay, so what is the value of f of g of 0? So we're going to find out what g of 0 is, then plug it into the parentheses right there. So g of 0, g when x is 0, so x is 0, then g would be negative 2. So we're finding f of negative 2. So now, f of negative 2, meaning our x is negative 2. So when x is negative 2, f is going to be 4. So that would be our answer. So now, using the same table, let's answer number 24. If f of m is equal to 6, what is the value of g of m? So sometimes they'll do this where like they replace it with a different variable. So like instead of x, they're using m right there. It's the same sort of thing. It's just to confuse you. So it's basically asking like at what x value, you have to figure out at what x value does f equal 6. So f equals 6 when the x value is negative 1, or in this case m. So when this is negative 1. So we're trying to find now, if we want to find g of m, we're finding g of negative 1. So g, when x is negative 1, is going to be 3. What do you say? Hold on. Someone said something about negative 5. Wait, hold on. I erased the problem before. Why did I do that? Someone said negative 85 plus 80 isn't 5, it's negative 5. Did I do something wrong? Hold on, let's see. Let me do that really quick. So negative 10 over here, negative 17 a's times 5 plus b. So then that's going to be negative 85 over 8 is equal to negative 10 plus b over there. So then that's going to be negative 80 over 8, and then plus 85 over 8. So it's plus 85, not minus 85. So it would be positive 5/8. It's right, positive 5/8. So then let's go to number 25 over here. So for number 25, we have h of m over 4 is equal to 21, and h of x is equal to all this. What is the value of m? So we're finding m. Again, just trying to trip you up with different variables. So if we're doing h of m is taking the place of x. So if I want h of m, it's going to be negative 5m plus 4 up there over 4 is equal to 21. So now I'm going to multiply by 4 on each side. So then I get negative 5m plus 4 is equal to 84. Thanks for the likes, guys. So now I'm going to subtract 4 on each side. So I get negative 5m is equal to 80. Now I'm going to divide by negative 5, and I think that's negative 16, right? Yes. So then I get m is equal to negative 16, so it would be b. So let me just erase that. Oops. Okay, so now for number 26, we have these two functions. Which of the following is equal to f of 3? Okay, so let's start by doing f of 3. So everywhere we see an x, we're going to put a 3. So 5 times 3 minus 4. So it's going to be 15 minus 4, which is equal to 11. So f of 3 is equal to 11. So we need to figure out, okay, because of how they're writing this, like g of what equals 11? So when does the whole function g equal 11? So let's set that up. So 11 takes the place of g of x, and we're trying to figure out, okay, what x value does that? So I'm going to add 5 to each side. That's going to give me 16 is equal to 4x. Divide by 4 on each side, I get x is equal to 4. So it would be g is 11 when you have 4 as your x value, is how you can think about that. So g of 4a. Okay, so now let's go to number 27. Use the table below to answer the question. So this table, if the function m is defined by m of x is equal to h of all that, what is the value of m of 2? Okay, so we want to find out m when x is 2. Why is it not writing? There we go. So everywhere we see an x, we're going to replace it with 2. So 4 times 2 minus 3 there. So we have h of 4 times 2 is 8 minus 3. And this is what's equal to m of 2. And then we have to say, okay, that's going to be equal to h of 5. So h of 5 is the h value when x is 5. So let's go to where x is 5. The h value is 6. So that's our answer, 6. And then now, let me just erase this. And let's go to number 28. So for number 28, we have this graph. Let me go down a little. And then it says, based on the graph shown above, someone said, oh yeah, again, the problem is it's not negative 85 plus 80. It was 80 minus 85. Or sorry, it wasn't minus 85. It was the opposite, where, what was it again? I forgot with the numbers, but I just did it again right over here. Negative 80 plus 85 over 8. So it's this. That's why. I think you just, like, misread where the negative was or something. Okay, so let's go to number 28. Oh, someone said they already got it. Let's see if you're right. So for number 28, based on the graph shown above, which of the following is equal to the length of line segment FG? So this is FG right here from here to here, like this portion. So you'll see there's a little right triangle right here. So this has a side length of 2, this has a side length of 4. So the length over here, this part, which actually I'll just label with an X. The hypotenuse we'll label with X is going to be, if we solve for X, we have the length of that line segment. So remember, you can use Pythagorean theorem with right triangles. So you could do 2 squared plus 4 squared equals X squared. So then that's going to be 4 plus 16 is equal to X squared, or 20 is equal to X squared. So if you square root each side, you're going to have that this just is X, and then that's going to be, whoa, why did it do that? And that's going to be the square root of 20. Let me just move it up here. So square root of 20, you can break down into 5 times 4 on the inside. 4 is a perfect square that you can take out. So the square root of 4 is 2, so then it's 2 root 5. So yes, you are correct. It would be B, 2 root 5. Okay, so now let's go to number 29. So for number 29 right here, we want to figure out what, based on this function above, what is f of 9 minus f of 6. So basically you just find out what f of 9 is and then subtract what f of 6 is. So let's start by finding f of 9. So f of 9 means that 9 is going to replace each of our x's. So we're going to have 9 cubed plus 2 times 9 minus 15. For the person that just asked to go back and take a quick picture, this is getting uploaded to YouTube after this, so you'll be able to see it on YouTube. So 9 cubed plus 2 times 9 minus 15 for f of 9. So we have 9 times 9 times 9. I don't want to trust my brain this late at night, but I think it's 729. Let's see. Where is my calculator? 9 times 9. I have to use my computer calculator. 729. Yeah. Okay. So 729 plus 18 minus 15. So plus 18 minus 15 is plus 3. So 729 plus 3 is going to be 732. So that's going to be what f of 9 is. Now we have to figure out, so I'm going to just write it up here, that we have 732 for f of 9 minus whatever we figure out f of 6 is. So let's figure out what f of 6 is now. So f of 6 means everywhere there's an x, we're going to plug in a 6. So it's 6 cubed plus 2 times 6 minus 15. 6 times 6 times 6. I do not remember that one right now. Let's see. 6 times 6 times 6. I was going to guess that. Oh my god, but I didn't want to sound stupid. Okay. Sorry, I got annoyed with myself. Okay, so 6 times 6 times 6 is going to be 216 plus 12 minus 15. So now this is going to be 12 minus 15 is negative 3. So then it's going to be 216 minus 3 is going to be 213. Okay, so now let's erase all that. So now, and don't make fun of me for having to do this upside down, otherwise the numbers are going to like flip all in my head. So then we're going to subtract this, and I'm going to get 9, 1, and 5. So 519. As we do PEMDAS, do we do it as it goes in order? So with PEMDAS, one thing that you have to remember, like the A and the S don't really matter. I mean, it matters in relation to the other ones, but the one that trips people up, like technically you go in order, except if you have multiplication and division, you do what's left to right in that order. So like, let's say that you have 18 divided by 6 times 3. Because it's the MD that you're deciding between there. When you get to that point, you would do whatever's to the left first. So you do the division first. 18 divided by 6 is 3. And then 3 times 3 is 9. So that's like, yes, you do PEMDAS in order, but like that's the exception part of like when you get to this portion, the MD, that you have to take that into account. Okay, so then let's go to, let me get water really quick again. No problem. Okay, so let's change the pencil. Okay, so for number 30, we have f of x is equal to that. For the function shown above, f of m is less than m for which values of m? Okay, so f of m means that we're just replacing the x with m. So we're just going to do f of m is equal to m cubed. So that's the same thing. F of m is the same thing as m cubed. So it would be m cubed is less than m. So probably the easiest way to go about this is just start plugging in to see like which of the m values works for this. So I would start with like the integers first, like especially the easy ones like 1. Like 1 cubed, that's not going to be less than 1. Now let's do 2. 2 cubed is 8. 8 is not going to be less than 2. Again, I'll tell you the faster, more efficient way at the end, but this is the way most people would have to do it. Then I would do 1/2 cubed is going to be 1/8. So then you have 1/8 is less than 1/2. That is correct. And if you want an easy way, like if you can't tell that like 1/8 is less than 1/2, just like kind of instinctually, what you can always do, and this always works, is multiply the bottom of one times the top of the other. So like 2 times 1 is 2. And then do the same thing. 8 times 1 is 8. And then you just compare these numbers. So 2 is less than 8. So 1/8 does have to be less than 1/2. So that's like a little shortcut that you can use. So that works. But then you would see when you plug in 3/2, like if you just want to prove it to yourself, like 3/2 times 3/2 times 3/2. Wait, 3/2 times 3/2 times 3/2. That would be 27/8. And we would have to say, okay, is that going to be less than 3/2? Definitely not. So that's like the plug-in way. Now, the more efficient way is like once you got to this step right here, is to say, okay, if we have a fraction that's less than 1, like if we keep multiplying by a fraction less than 1, it's going to keep getting smaller and smaller and smaller. So like then what we started out with. So logically, it has to be a fraction. If we have the option between stuff that's greater than 1 or a fraction that's like less than 1, then it would have to be the fraction that's less than 1a. So someone asked something. Hold on, I got sidetracked. What book do you use to study? This is my book. You can find it. My website's in my profile in my bio. It's ag-tutoring.com. I have like a bunch of these chapters I've uploaded for free on the website that I used to upload it. And then I have some that are like, obviously, like you could buy the whole book paid on there as well. And then someone asked, would you be able to do a video on non-separable ordinary differential equations? So like if you want me to, if you have specific requests, like you can always tag me in the comments of a video that like you don't know how to solve or like something similar, like a similar problem. I think I even have the Q&A feature on my thing, and like when I have time, I'll make a video. So any tip, I don't understand this. I'm in algebra 1. I would just encourage you to like keep watching the videos and kind of, I would probably go to like the ACT video first, because I do like a little intro in that video on my YouTube channel of like stuff you need to know and remember for this type of stuff with functions. So that might be helpful for you. Or you might just not have like really gotten into it this year, but you definitely were introduced to functions in pre-algebra. You probably just don't remember. Any tips for the SAT math? Keep getting a 580 on it. I would keep practicing with the practice tests that they have, and I would do stuff like these types of problems. Like, I mean, I'm biased, like this is my book, but I wrote it for a reason because I didn't think that stuff was up to par with what I wanted that was already out there for my students, because I tutor on the side. So like I would do like books like this, and also like practice tests after practice test after practice test. Doing the corrections also is really important. A lot of students for some reason just practice and they never do the corrections, which never made sense to me. But yeah, corrections are important. Is your math for digital? Yes, this is the digital book. Like not meaning like it's only digital on here. Like I wrote it specific for like the digital, like I updated it for the digital one. Okay, so now let's go to number 31 right here. So the functions f and g are defined as this right here. What is the value of f of g of 3? And actually, this book is harder than the digital SAT. So like if you can get through this book, what I did was I included problems that were the digital SAT format, but if I felt like there was a way to like test you on a bunch of different concepts in like one problem concisely, I like changed it up a little bit. Like it's not going to make it harder than what like the SAT would actually ask you. So let's go to number 31, the functions. Okay, what is the value of f of g of 3? So we're going to start by finding out what g of 3 is. So let's do that. We're going to plug in a 3 for x. Everywhere we see x in this function. And we're going to say 3 squared minus 3. So 3 squared is 9. 9 minus 3 is equal to 6. So g of 3 is equal to 6. So instead of g of 3, I can put a 6. So now I'm finding f of 6. That means that everywhere there's an x in my f function, I'm going to put a 6. So it's going to be 6 cubed plus 2. 6 cubed is 216. And then plus 2, so that's going to be 218 as my answer. Okay, so let's go to number 32. The graph of the function f has a y-intercept at 36. So when they tell you that, they gave you a point technically, because y-intercept means that the x is 0. So we have 0, 36. And then x-intercepts at 3 and negative 4. Again, they gave you 2 more points, or I gave you because I wrote this. And it's going to be 3, 0, because the y is 0 for x-intercepts, and negative 4, 0. Which of the following could represent the function f? Now, what you could do technically is plug in these values to figure out like what's the which of these is the correct equation. That's probably what most students are going to need to do. Or you can remember, okay, I would start with like the x-intercepts, and I would say, okay, if I want my my function f of whatever, f of x, to equal 0, that means that the factors, one or more of the factors, must equal 0. So I can figure out, okay, when that means that like what's inside the parentheses basically each time. If I set it equal to 0, I have to get 3 or negative 4 for x, my x value. If those are truly the x-intercepts. So let's look at this really quick to see if there's anything we can easily eliminate. So with this negative 4 plus x, if I set that equal to 0, I'm not going to get negative 4, because if I plug in negative 4 there, negative 4 plus negative 4 does not give me 0. So I can easily eliminate a. Now let's try b. Negative 4 plus 4, that does give me 0, so let's keep trying. 4 minus negative 4, minus and minus is plus, so that would be 8, so it can't be C. And then now let's try it for D. If I put negative 4 in there, negative 4 plus 4 does give me 0, so that works as well. So now I'm just going to have to look between B and D right there, and you'll see that both of these have, what do you call it, like 3 as your, what's the word? Oh my god, I'm losing it. 3 as your x-intercept, because when you plug in 3 for x, you get 0. 3 for x there, you get 0. So now that you've eliminated half the answer choices, now what you can do is plug in this guy right here to help you out. So let's say that f of x is 36. That means that when f of x is 36, we have to have 0 in for our x's, so 0 plus 4 is going to be 4. And then 0 minus 3 is going to be negative 3 squared. So then it's going to be 4 times 9, because negative 3 squared is 9. So then that's going to be equal to 36, which is what we wanted. Now let's do the same thing with D to disprove that it's D. So 36 for f of x, and then my x has to be 0. 0 plus 4 is 4. 0 minus 3 is going to be negative 3. That's going to equal negative 12. That does not equal 36. So it can't be that one. It has to be B. Okay. Let me just erase that right there. Okay. So now for number 33, use the table below to answer the following question. Given this, what is the value of g of 4? Assume b and c are constants. Okay. So g of 4 is what we need to find, and this is supposed to match the table. So we've been given a bunch of points in the table. So like we've been given, for instance, 0, 5, or 0, -5, sorry, for one of our points, 1, 2, and 2, 51. So we can use this information to help us figure out what B and C are, and then we can have a full equation that we can plug in for x to find g of 4. So let's start with 0, -5. So 0 is going to be my x that I plug in, and then -5 is going to be my g of x. So I'm going to have c plus b times 0 to the 3rd power is equal to, and then g of x is going to be -5. So then 0 cubed is 0, times b is just 0, so then I get c is equal to -5. So I'm going to just write that up here so I can use the space down here for calculations. So now I'm going to erase that. I know what c is. So now I'm going to use 1, 2, and I'm going to say, okay, I know that c is -5 now. So -5 plus b, and then my x is going to be 1, and then I cube it, and that has to equal 2 for my g of x. So now I could say, okay, 1 cubed is just 1, and then 1 times b is just b, so I have -5 plus, hold on, that's going to bother me. So I'm going to have -5 plus b is equal to 2, so then I'm going to add 5 to each side, so then I'm going to get b is equal to 7. So now I know what b is. B is 7. So b is equal to 7. So now I have a complete equation. I have g of x is equal to c is -5 plus b is 7 x squared. So now I can easily find g of 4. G of 4 means that everywhere that there's an x, I'm going to put a 4 now. So I'm going to have -5 plus 7 times 4 squared. So that's going to equal -5 plus 7 times 16. So 16 times 7 is going to be 112. So it's going to be 112 minus 5, which is going to be equal to 107. Hold on. What did I do? Because I have the key next to me just in case like I get tired and like I make a silly mistake, and this is the one that I've gotten wrong right now. Is the key wrong or is that wrong? Oh, it's cubed. Yep, you see, this is why I have the key next to me, because I know if I do these late at night, something's gonna happen. Thank you guys for catching that. Cubed. Did I do that when I was solving for, well, actually, it doesn't matter if I was doing when I was solving for B and C. Okay, so now it's going to be cubed, sorry, is what I meant to write. So we're going to plug in 4 everywhere that we see an x, and it's supposed to be cubed for the function. So it looks like this, and then we're going to now say, okay, I have -5 plus 7 times, it's going to be 16 times 4, because I forget what this is. That's going to be 64. Okay. 64, so now I have 64 times 7, 8, carry the 2, 44, 448. So we have -5 plus 448. It's going to be equal 443. Is that what I have? Yes, that is what I have. So now I have it right. There we go. Okay, thank you guys for correcting me. So then let's go to number 34 now. So for the functions shown above, P models the total cost in dollars of manufacturing X tablets in a tech company. The function S models the revenue in dollars earned from selling X tablets. In order to earn a revenue of $2,750, how many tablets would have to be sold? So revenue is the S one. So the S of X part is going to be replaced by, by the 2,750. And then I have that that's equal to 5.5x. Remember, x is the number of tablets, which is what we're trying to find. So I just have to divide by 5.5 to get what x is. You have a calculator on this, so I'm just going to go ahead and use my calculator. 2750 divided by 5.5, 500. So it's equal to 500 B. Okay, so now let's go to this one right here, number 35. So same sort of setup, but like a different question at the end. Which inequality models the number of tablets that must be sold to earn a profit of $15,000 or more? So remember, P is the total cost, and then S is the revenue. So in order to find profit, it's going to be your revenue minus your cost. So we're going to have to do S of X minus P of X to get the, not the revenue, the profit. And then it says that we want to, the number of tablets want to earn a profit of $15,000 or more. So that means that this, our profit, has to be, it could be $15,000, it could be $16,000, like $15,000 or more. So this has to be greater than or equal to 15,000. So, oh my god, I hate, when I look at this, it like flips around. Hold on. I think that's A. There we go. Okay, so let me just make sure that that's right, because I don't trust my brain right now. Yeah. Okay, so we're almost done. This is the last problem, then I'll answer any questions afterwards. So, number 36, we have this. The function f gives the predicted average score expressed as a number of points for a student who is participating in the school science fair based on the number of years t that the student has participated in school science fairs. If a student is entering the science fair for the first time, then what is the predicted average score for that student? Okay, we want to know predicted average score, which is going to be like this part right here, the F part. And they're entering the science fair for the first time, and based on the number of years t that the student has participated in science fair. So if it's the first time, they've never participated in the science fair before. So that means that t has to equal 0 because it's their first time. They've never experienced it before. So t is 0, meaning everywhere there's a t, there has to be a 0 instead. So it would be f of 0, B. Let me just double check again. Yeah, B. Good. Okay, guys. So, that is it for the questions. We're going to be doing, like, math problems. If you have any questions specific to, like, about the digital SAT or ACT or just, like, high school, like, college consulting stuff, put them in the comments and I'll answer them. If we don't get any questions, then I'm going to head out, and I'll probably do a live tomorrow if I have time. I don't know. Let me see my schedule. What's tomorrow? Tomorrow's the 30th. I mean, it's probably going to be at random times. I would just, like, pay attention. I think you can get, like, notified when I go live or something if you do something on my profile. But, yeah, it's just going to be, like, whenever I'm in between sessions and can do it tomorrow. Probably in, like, the evening time. So, does anyone have any questions that they want to put in the comments? Otherwise, I'm going to head out. Thanks for the likes, guys. Do you post all of your lives on YouTube? I just found your videos and love them. Oh, thank you. Yes. So, I mean, I don't double post. So, like, when I'm doing these on the live, it's my problems. Unless I've gotten, like, permission from another author and, like, I'm using their book. But most of the time it's my problems. So, like, it'll be in the playlist that corresponds to my book for that. So, like, for instance, today I did the functions for digital SAT. So when I upload it, it's going to be in the digital SAT functions thing. But, like, if I did this chapter again a couple weeks from now, I already uploaded it once. I'm not going to upload it again. I'm just, like, uploading it now for the first time because I just came out with this. Is it the same profile name on YouTube? Yes, AG Tutoring. Also, my YouTube is linked in my profile. Okay, thank you so much. I'll definitely check those out. Yeah, no problem. Okay, it looks like we don't have any other questions. Have a good night too. I don't know your name, but it says E. No problem, guys. I will see you guys tomorrow sometime. Probably like later in the afternoon, early evening-ish. Bye, guys.